Before lunch. Okay. We're live?
Yep.
Okay, we're live.
Good afternoon. I'm Kayvon Stassen, Chair of the Awards and Facilities Committee on the National Science Board. Fellow committee members include Committee Vice Chair Suresh Babu, Roger Beachy, Aaron Dominguez, Matthew Malkin, Julia Phillips, and Merlin Theodore. I'd also like to welcome new NSB members Juan Gilbert and Jeffrey Isaacson to the committee. Welcome. We look forward to working together for this board cycle, which runs through May 2026. We have one item on the agenda for today's open session. We'll hear an update from NSF on plans to recapitalize the Summit Station in Greenland. Materials associated with today's meeting are available in the A&F Committee Diligent Board Book. Before we get started, I'll note that the committee previously approved the minutes of the December 3rd open meeting by email, and those minutes are also available in the board book. And so without further ado, I'd like to hand it over to our NSF colleagues. We are joined by James McManus, Jean Cotton Allen, Jennifer Mercer, and Al Rira. Please, and thank you.
Thank you, and good afternoon, everyone. My name is Jim McManus, and I'm the Acting Assistant Director for Geosciences. I'd like to introduce the information item for Summit Station Modernization and Recapitalization Project, also known as SUMMER. This project will revitalize the existing Summit Station located near the center of the ice sheet of Greenland. As you'll hear, Summit Station has been a hub of innovative science and discovery since the 1980s, starting first with the Greenland Ice Core project and since expanding across disciplines. The SUMMER project has been in development for many years, and in September of last year was approved to enter the major facilities preliminary design phase. We are excited to share with you an overview of the science supported by Summit Station, the SUMMER design plans, and the path forward. Dr. Jennifer Mercer, Section Head for Arctic Sciences in the Office of Polar Programs, will give the presentation. Jen, over to you.
Thank you, Jim. Good afternoon, and thank you for this opportunity to give you an overview on this upcoming and very exciting project called Summit Station Modernization and Recapitalization, or SUMMER for short. Just to orient us a bit, I'm going to first introduce you to Summit Station and its role in the Arctic, and then I'll talk about its relevance, history, and the important science that is currently being done there. Then we will see the existing facilities, review the project scope and proposed facilities, and finally, I'll walk you through the timeline. Summit Station is the only high altitude, high latitude, year-round research station in the Arctic. In addition to the important science supported there, which I'll talk about in a moment, the station is important to national security through our presence and to diplomacy for both science and foreign affairs. We also support research efforts by other agencies, such as NASA and NOAA. And in addition, there are several international partnerships for collaboration at Summit with our allies such as Denmark, Greenland, Norway, the UK, and Australia. For example, one of the largest projects is co-funded by the United Kingdom's Natural Environment Research Council. These collaborations allow for more extensive studies than just the US could undertake alone. Summit Station was established at the top of the Greenland ice sheet in 1989, and I am going to show you a very short video that highlights that initial effort.
This Greenland Ice Core was collected from 1989 to 1993, working about 5 months during the summer. We drilled 24 hours a day.
And in 1993, after 4 years of intensive drilling, researchers retrieved the deepest ice core in the world at that time, obtaining over 3 kilometers of ice and about 1.5 meters of bedrock. This core opened a new window into paleo-environmental investigation, providing an unprecedented high-resolution, continuous record that is still being used to understand past climates and help predict future change. Year-round operations at the station began in 1997. As we all know, Greenland's ice sheet has taken an increasingly stronger presence in world news. And the country of Greenland itself has recently garnered public attention. The Greenland ice sheet holds about 7 meters of sea level rise and has shown to be speeding up in degradation. Additionally, Greenland is thought to be very resource rich under all of this ice for minerals, including rare earths, and fossil fuels. Greenland's importance, though, goes back much further than the present. It was strategic to the US and its allies during World War II, with the US building a lot of infrastructure there. Then it was again very important during the Cold War and served as a foundation for several early warning detection systems to track missiles from Russia. It was also the site of Project Iceworm and Camp Century, which had military objectives to establish bases under the ice, and which ultimately taught us as a nation a lot about ice sheets and snow mechanics. It's knowledge that we still apply today in both the Arctic and Antarctica. Very recently, sediments from a core taken there have given new insight into what Greenland would look like in an ice-free environment. And finally, I'd like to note that the US Air Base, Thule Air Base, was renamed as Patuxent Space Base after the Space Force was established and to better reflect their mission, which includes science support. And that brings us to the current science. So I'm going to highlight for you 5 significant areas of science interest at Summit. First is the study of surface mass balance of the Greenland ice sheet, which is helping to quantify and model the ice sheet's contribution to global sea level change. Next, Summit is optimal for atmospheric data collection for aerosol chemistry and cloud properties, as well as ozone concentrations over the Arctic. This is because of its high altitude, which provides access to the free troposphere. It's so optimal, in fact, that Summit has been designated as one of 3 Arctic super sites for the comprehensive study of clouds and atmospheric radiation. Third, the daily data collection there supports weather and climate prediction models in the Northern Hemisphere, as well as validation of atmospheric chemistry models. And then fourth is the study of ultra high energy neutrinos and their links to astrophysical events in the universe, as well as their interactions in the ice. And Summit has been assessed, and the ice properties have proven to be very favorable for the detection of high energy neutrinos. Sorry. And in fact, the array that is being installed there will be the only one in the Northern Hemisphere once it's completed. And then lastly, Summit Station is more accessible than South Pole Station in Antarctica, and investigators are increasingly interested in working at Summit Station. We anticipate this interest to grow since NSF has recently directed the research community to explore alternatives to South Pole Station. All right, Summit Station is located at the center of the ice sheet on the map on your left. And for reference, the North Pole is there at 90 degrees north, and Patuxent Space Base is here at 76.5 degrees north, which is approximately the same latitude as McMurdo Station is south in Antarctica. Summit sits just a bit south of Patuxent at almost 73 degrees north. On the right, you see an aerial photo showing the current station infrastructure. Many of these facilities were not designed to be long-term, and as you can probably surmise from the photo, there was not a robust site planning effort when it was originally established. As a result, we have old infrastructure that is nearing the end of its service life, and we are not adequately supporting the current demands for research there. We are fully reliant on fossil fuels, which are expensive to transport, And we spend a lot of time and dollars keeping the structures above the snow surface because Summit receives a high amount of snow accumulation. The new station infrastructure will be located across the skiway, and all of this old infrastructure will be removed. For anyone who isn't familiar, a skiway is a snow runway for the LC-130 aircraft. And this is what we aim to do. A very deliberate planning effort has been undertaken, which considered the scientific needs and the well-being of the residents who work there. The result will be replacing those 30 existing structures that you saw in the aerial photo with 5 elevated buildings and 2 surface level buildings. The elevated structures will mitigate the need for extensive snow removal. We will be incorporating new energy efficient utilities, including renewable power. And we will have infrastructure that has been designed to flex to the evolving needs for science. And I'll also note that we have a 3D model here on the table if you're interested in looking at it. This project has recognition at the national and international levels. It has been identified as a deliverable for the National Strategy for the Arctic Region, or the NSAR, which was released by the previous administration and which sets an affirmative US agenda for the Arctic over the next 10 years. It is also under consideration as a deliverable for the upcoming 5th International Polar Year, or IPY, which will take place in 2032 and 33. There have been 4 previous IPYs. The first was in 1882, then in 1932, then in 1957, which was also called International Geophysical Year, or IGY. And then the last one was in 2007. These IPYs are collaborative international efforts with intensive research focus on the polar regions. In the last IPY, one of the US deliverables or outcomes was the Arctic Digital Elevation Model produced by the Polar Geospatial Center and funded by NSF. We also are aware that the US Arctic Research Commission will be highlighting the need for robust research station infrastructure in the Arctic in their forthcoming report. So with that in mind, this schematic shows you the timeline. We are here, and where we've completed the preliminary design and we've started the preliminary design review process. In order to be completed in 2033 for IPY, we would like to start construction in 2027. And the project schedule then has us completing construction for an IPY event and final acceptance in 2033. Before I close, I would like to recognize and thank my team who are dedicated to the success of this project. I'm really proud and appreciative of all the hard work they've been doing. That is all I have for you today, and I'd be happy to take any questions, and I thank you for your time.
Thank you so much. We do have time for questions. And Julia's looking for the virtual hand, but I see her physical hand, so we'll go with that. Julia Phillips.
Thank you, Kayvon, and thank you. I'm looking forward to learning more about this as we go further. You must, I realize it's early to have a cost estimate, but you must, know, 100 million, 10 million, or $1 billion, or, somewhere in there between probably.
My understanding is we can't talk about budget in the open meeting.
Okay. Well, then the second question is this going to be like South Pole in the sense that you need to raise the buildings now and then?
Yes, and in fact, we do that so that if you, in the aerial photo, you saw one building, I think, that's elevated, and we do raise that one periodically, but the rest of the buildings are all surface level. There are a couple of other smaller elevated ones, but of the 30, it's only maybe 4 elevated. And so when they're on the ground, almost every year we have to move them because they get buried with snow drifting. If Summit receives almost a meter of snow accumulation per year, plus drifting from blowing snow, South Pole Station only receives about 8 inches of snow per year. In addition, we have been working over it's been about 15 years now, on a new lift system design, which we've implemented. We've already tested the prototype on that one building at Summit. So at South Pole Station and previously at Summit Station, the the way we would do it was add steel onto the legs and then pull the building up. So we called it the endless leg system, where you just have steel going down in the snow. What we're doing now, though, are a single steel leg with a footer, and you can jack that leg up, push snow under it, set it down, and do that. And then you can level the build. It has a leveling system as well. So we will no longer be hauling steel up there every other year to lift the building.
And how often do you anticipate having to do that? I mean, it sounds like pretty frequently, right?
Well, these, if you look at the model here, we've actually had contractors, and the U.S. Army Cold Regions Lab has been involved in this as well, doing wind tunnel modeling to look at the optimum height and distance between the buildings to minimize doing that as little as possible. So right now, I don't know if you have an estimate for how often we'll have to do it, Al, but
Our current estimate is about 3 years, once every
Okay.
3 years.
Thank you. And so I assume that when there are numbers, that will be included in whatever numbers there are.
yes.
Okay.
Roger Beachy.
Thank you for the introduction. There's a lot that we need to learn about the station. I'm pleased to finally hear something mentioned about it. We focused on the other end of the world instead of the Arctic. What are the how do you see the research being different? One, and secondly, you're way inland from the area, from the edge of the ice to where Summit Station is. What kind of logistics problems does that present? And do you have a real good grasp of everything necessary to make this project a success? Given that you have just these scattered buildings, this changes the dimensions of activity there remarkably. It has potential to. And I'm just interested in that plan of action. And what does the investment get us?
Okay, I think I heard
3 questions.
three
only?
questions, right?
Okay.
How will the research be different?
Distances in and how does construction, what challenges does it raise?
Yep.
And can you adequately estimate what that cost is going to be and what it's going to take to make that a
Yep.
reality? And what was the third?
It was
not
logistics
program.
challenges, I think.
Yeah.
Okay. When you're asking about the research, do you mean how will it be different in the future, or how is it different from South Pole?
How is it different? And how will it be different than the South Pole research? Or do you
Okay.
expect a lot of similarities? And the third question was, what do we get? What kind of outcomes can we anticipate from this kind of research? Given that we're under the challenges and the
Yeah.
Committee on Strategy to identify not just outputs but
Yeah.
outcomes, I'm just looking at down the road. How do we start talking about this
Yeah.
in a
So-
real positive way?
Yeah. Okay. Great questions. Thank you. As far as the differences in science, a lot of the science at South Pole is about astrophysics. It's about other things as well. But Summit started very differently. Summit started as a drill to drill an ice core and produced at the time the highest resolution ice core. And then it continued because we have that ice core record there. It has continued for atmospheric measurements as well as cryospheric measurements because it's all pinned then to that core. So it has a long history in those two disciplines in both atmospheric and cryospheric science. It's actually just been recently that the astrophysics community has been expressing interest in wanting to work there, partly because because South Pole is not as accessible. So we expect that it's really expanding into that space but these other disciplines will continue. In addition, so the Greenland ice sheet is not as big as Antarctica. Greenland's about three times the size of Texas, and it's rapidly deteriorating. So understanding what's happening at the center, because we're also monitoring and drilling, on the margins and halfway up the ice sheet and everything. That's kind of our where everything's pinned to, right? NASA actually anchors the satellite data for ICESat-2 to Summit Station. We have technicians that do regular surveys there to calibrate the satellite. So there are a lot of different things there in terms of the research. We've had more and more interest also on for testing like technology. We facilitated a project there for the military a few years ago, testing some new polar technology. And so I think that right now we don't have capacity, we don't have bed space to really support much science there. In fact, until a couple of years ago, people were sleeping in tents. So this will expand what we're able to support for the science interest at Summit Station.
I could jump in for a moment before you go to the next one.
Sure.
I'm just going to add one point, exactly what Jen said. And in many ways, Greenland and what we do at Summit and Antarctica and what we do at South Pole are complementary. And doing the ice core at Summit is complementary to what we learn in Antarctica. And you have the Arctic and the Antarctic, and you put those two together and you have a much richer understanding on the astrophysics side, on the glaciology side, on the oceanography side. So they really come together and give us much more.
So I'll move on to your second questions unless you want me to clarify anything on the science.
No, that's fine.
Okay.
I am curious about the challenges, the logistical challenges,
Yeah.
and whether or not how you estimate whether or not you can it's $1 billion or 5 or whatever.
Yep. Okay. So yes, we'll be doing construction inland. The only way to get things there is by air. We did try traversing in Greenland in the last decade, 2010 through 2016 or 17. But the margin of the ice sheet is deteriorating so rapidly that it ended up, it's not feasible and not safe. So it's by air. And as you know, we rely on the LC-130s. We are actually also proving the concept to do airdrops for the big, dumb, heavy things. So we can't airdrop instruments or doors and windows or people, but we can airdrop 2x4s and steel and stuff. So we're offsetting our delivery transportation needs with airdrops. The operational season is very limited because it's cold and it is dark in the winter. So we're looking at intensive construction seasons that start in April and end in September, putting up the shells of buildings and then doing the interior fits in the winter when they can work indoors. That's similar to how like Scott Base did their base. They build the shell and then you do the inside when it's cold out. So there are those logistical challenges, and we do have to be able to support construction crews during that time.
Yeah, thank you. That's a good start.
Okay.
Since we learned last fall about the challenges with the C-130s,
Yeah.
I mean, as we visited that site
Yes.
in New York, we realized, recognizing this will put additional pressure on that limited force and decreasing force, as we found out. And it's going to take some real commitment from Congress to allow that to enlarge and expand. Otherwise, your timeline seems to be a wish list.
Well, we've spread it out over, I guess it's about 8 years now. But yes, it will rely on the C-130s. We're trying to make it so that we're not asking our schedule and our flight planning using airdrops so that we're not asking for more flights than we normally receive from them. And they're also working on planning tempos in Greenland to support us.
Thank you. I'll turn.
Sure.
Yeah, well,
As far as let me just speak really generally, 1 or 2 sentences on your question about how to estimate the cost. So we have to go through the process of independent government estimates. We have an outside review coming up to look at things. And so there's a whole process there that goes into estimating the cost before it's finalized.
We got started just a couple minutes late, so if you'll indulge us for a few more minutes, we have 2 more questions, one from Jeffrey and then one from Suresh.
Thanks. At the outset of your presentation, you mentioned partnerships. Can you say a few words about how engaged partners have been in the design and planning? NASA, NOAA, possibly Space Force, and especially our international partners?
Yeah. So NASA has not, we've run periodically, we provide them with updates to the design, and we also know what their historical population pressure has been on the station. So that's part of it, just knowing what their demand is. Also, we have to design around the locations for calibration of the satellite. So where those surveys are done, we can't impact that area. Also, the Smithsonian Astrophysical Observatory would like to take a telescope there. So we've had a lot of conversations with them about what that would do to station population and what would be needed for that. So we've had conversations with them, with NOAA in terms of measuring. A lot of it's done by a science technician for them, but it's a long-term atmospheric observations that are taken there. So knowing what they need for storage, for samples, and equipment for that stuff. As far as international collaborators, our main international collaborators that we're talking with about the design is the country of Greenland. They have a robust research community there, and so we want to make sure that they feel that they can come there and do research. So we've been looking at making sure that we have room for that, and also because the station is in their country, looking at the way it's designed for international collaboration.
So have the interactions with the partners influenced the design? Have it led to any changes at this point?
I don't think anything really significant. I think our major goal is to make it efficient and flexible to the science demands. That's been one of the key, ideas going forward since we started, and we've carried that through the design processes to make sure that the station will be able to flex to the different types of science that would need to be done there, and differing populations as well.
Thank you.
Yep.
We'll do one final question from Merlin Theodore, and then to close this out, I'll just do a quick check-in about timeline for our next touch point.
Thank you, Kayvon. My questions also is in reference to partnership, and I don't know if you can answer this question here or maybe if this needs to be offline, but I'm curious in terms of partnership, because I understand this will be probably a significant budget.
Mm-hmm.
Are there any sponsors from your partners on this project in terms of budget?
Right now, we do not have any financial commitments from our partners.
Thank you.
Yeah.
Okay, well, thank you again. And so just to clarify for everyone, our next touch point on this for the board will be, what do you have for that?
Linnea, you want to take that?
Yeah, it would be when the project is included in a future budget request to
Okay.
Congress.
Okay. All right, great. Well, thank you again.
Thank you.
Would it be asking too much to leave the 3D model a little bit longer? We're going to go into closed session.
Okay.
So you'd have to come back and get it after that if you don't mind, but we're not going to be able to kind of spend time looking at it right this second. I would like to look at it.
Sure.
Thank you.
Yeah, we can leave it and we'll come back and get it. I don't know what time. 5 o'clock.
Thank you.
Okay, one of us will grab